Welcome everyone to the study guide review video for the 7th grade Unit 4 quiz. Question 1. The value of a car decreases over time. This year, Faria's car is worth $18,000. If the value of Faria's car decreases by 7%, what will her car be worth next year? Okay, so this is a percent change, percent decrease question. We're going down, decreasing by 7%. And we want to begin by recognizing that 7% is the same as 0.07. That's the decimal form of 7%. Okay? So in order to figure this out, there's sort of two different ways. One way is we can find 7% of 18,000. So we can multiply 0.07 times 18,000. And that's going to tell us the amount of the decrease. So that's going to equal $1,260 that we're decreasing by. Okay, and then we can take the initial cost of the car, $18,000, and subtract the $1,260 that we're not paying. Okay, and then we're going to end up getting $16,740 is the new price of the car next year after it's decreased by 7%. Okay, that's two steps. Students tend to see it's conceptually, but that makes more sense to them, but it is like a little bit more work. The faster way to do it is to recognize that a 7% decrease means we're going from 100% down to we're paying, it's 93% of the $18,000, right? So if it's gone down by 7%, we're paying 93% of it. So we can just directly do 0.93 times 18,000, and that will directly give you $16,740. So totally acceptable. Either way would be fine on the quiz. You would select the multiple choice question. That is right for that. Okay, cool. Question 2. Myra bought X grams of rice. Anika bought 24% more than Myra bought. Select all of the equations that represent the relationship between the amount of rice that Myra bought X and the amount of rice that Anika bought Y. Okay, so here we have a 24% increase. So that means it's 24% more than the 100% that Myra bought, right? Because Myra is our X. We're seeing Myra as like the original, and then Anika's 24% more than that. So that is 124% of Myra. That's how much Anika has. 124 is equivalent to 1.24 as a decimal. So we get this first one, Y, which here is representing Anika, is 124% of what Myra bought, or 1.24 times X. Okay, so that's going to get us the first one, and then this third one is also going to be correct, right? We're taking a 24% increase, so we're adding 24% of what Anika bought to what Anika bought, right? So X here is like our 100%. This is Myra, so it's our original plus 24% of the original. Okay, and we do know that we think about in simplifying this expression in general. X is the same thing as 1x. So if we have 1x plus 0.24 times x, right, we're going to get 1.24, 1 24 hundredths x. So these are all equivalent equations. Oh, sorry. There you go. All equivalent equations. Cool. All right, question 3. In 2021, the monthly rent of an apartment was $2,000. In 2022, the rent of the same apartment was raised to $2,150. What was the percent increase in rent from 2021 to 2022? Okay, so here we know that we can find the percent change by finding the amount of the change and then dividing that by the original amount. And then technically that's going to give us our answer as a decimal, so then we'll multiply by 100 to get it as a percent. So to find the amount of the change, we can subtract the new amount minus the old amount. So here, the new amount is 2,150. The old amount was 2,000. So it's a change of $150, right? And we can probably just see that looking at it. It got $150 more expensive. And the original, like the starting one, the earlier one, was $2,000. So we would divide 150 divided by 2,000, and then we multiply by 100, and that is going to give us our answer, which is going to be 7.5%. So it's a 7.5% increase. So people are paying 7.5% more for the rent of the same apartment than from the year before. Okay, and that's helpful to know because you can compare for different people who have different costs. The cost of the apartment is different. How much is it relatively increasing by, right? And that's the usefulness of a percent, is it's like the relative change. Okay, question 4. Question 4 gets at the idea that there's a proportional relationship between that, like a percent is like a proportional relationship. So we have that the equation y equals x minus 0.6 times x describes the relationship between the original price of clothes at a store x and the new price of clothes y. Write an equivalent equation to y equals x minus 0.6 times x in the form of y equals k times x. So this is the standard form for a proportional relationship, where k is our constant of proportionality, because we know in a proportional relationship, all you do is you multiply one variable by a constant number, and it gives us the other variable, the other quantity. So basically here we have x is my starting amount, and then I'm subtracting 0.6 times x. So that means that I have a decrease, because I'm subtracting, of 60% of the original price, because 0.6 as a decimal, that's 60% as a percent. Okay, cool. So if I'm thinking about my 100% as my starting, and then I subtract 60%, I end up paying only 40% of the original price of an item. So I can write that as y is 0.4 or 0.40 times x, the original cost of an item. That is mathematically equivalent to this equation. 1 minus 0.6 is 0.4. So these are equivalent, meaning you get the exact same answer. Any value of, like, it's going to give you the same solutions no matter what. Like, they're mathematically equivalent. Just like 2 plus 2 and 1 plus 3, those are equivalent. You're going to get the same thing no matter what, even though they look different. Okay, and now that we've written it in this form, is there a proportional relationship between the original cost of the t-shirt and the new shirt? Yes, because we can write an equation in this form, right? All we have to do is multiply x by a constant number, the constant of proportionality, and we'll get y, the new price of clothes. So yes, this is a proportional relationship, and the constant of proportionality is 0.04, or 40/100th. All right, and that's representing the fact that the new price of the clothes is 40% of the old cost of the clothes, right? Because we're taking a 60% decrease. Cool. And then finally, we're going to use that equation that we wrote, and this should be 4.1, to find the original cost of a shirt whose new price is $32. Okay, show how your work relates to the equation. So the equation I wrote is y equals 0.40 or 40/100th times x. Y represents the new cost of clothing, and x represents the old price. So here, my new price is 32, so I can substitute 32 in for new, and the old is what we're trying to find, so we can use x, right? That's like our unknown. Okay, And then we want to figure out, how would I find x? Well, here x, my original cost, is getting multiplied by my constant of proportionality, 0.40, to get the new. So to find x, I got to do the opposite of multiplying by my constant of proportionality. I'm going to divide by my constant of proportionality. And then I will get 80. So the original cost of the shirt is $80. Okay, that's how you use the equation to do it, right? So ultimately you need to divide 32 divided by 0.40 to get this answer. But here I'm looking for an understanding of a proportional relationship that you can divide, right? To solve this equation, you have the equation and it's telling you to find the old x, you divide. Okay, you can also kind of set it up this way because this is how the Desmos activity had it, right? The old to the new is $32. The old we don't know. We know to get from the old to the new, we multiply by 0.40. So to get from the new to the old, we have to do the opposite of that. Okay, divide by 0.40. And again, you'll get 80. Okay, this would give you the correct answer to part of it, but it does say use the equation. So I need some version of this to get this test. This question is like graded in two different parts. One part is like you get the right answer, but one part is you can connect it to the equation. So you need this too. But you're welcome to have both, or you can just have this. Awesome. All right, question 5. A car costs $11,000 before being reduced by $70 or $700. What was the percent decrease in the cost of the car? Round to the nearest tenths place, which means round the percent to have one number after the decimal point. Okay, so this, we are finding the percent decrease. So again, when we find the percent change, you find the amount of the change, okay, divided by the original amount. So in this case, we don't have to do much work to find the amount of the change. They just tell us it. It's reduced by $700. So we're going down by $700. And it said the car before being reduced by $700 was $11,000. So that's the original cost. And then if you divide that, you'd get the decimal form of the answer. We can multiply by 100 to get the percent form. And you'll get this, 6.36 repeating. As I wrote here, we want to round to the nearest tenths place, and I reminded us that the tenths place is like the place value right next to the decimal point, just that's the tenths place. So if we think about this, we want to round it to there, so we're either going to have 6.3 or we're going to have 6.4, and it depends on the number in the hundredth place to the side. In this case, the 6 rounds up the 3 to a 4, so it's about 6.4% decrease. Cool. Beautiful. Okay, last question, just a couple parts. A storekeeper increased the price of hats by 12%. A hat was originally priced at $18. What's the new cost of the hat? So increase the price by 12%. So we're going up by 0.12, 12%. Again, as with the first question, there's two ways to do this. You could find 12% of 18. Which is 2.16 or $2.16, and then add the $18, which is the original cost of the car, or of the hat, sorry, and then you end up with $20.16. So we find 12% of 18, and then we add the original price, because it's 12% increase, so it went up, adding by that amount to the original. Or we could recognize that a 12% increase means you're taking 112% of the $18. So that's 1.12 times 18 You multiply that, and that's directly going to give you $20.16. So either way is fine. You don't have to do both. When it comes to writing an equation, so now we're representing this generally. Write an equation to calculate the new cost C when the original price of a hat is P dollars. We could write two different equations based on this. Using sort of this strategy, the new cost equals 0.12, 12% of the original price. Then we add the original price. So it's just what we did here, except now we're using P for 18, right? Because that's the original cost. Or using this strategy, C, the cost, is equal to 1.12 times P, the original price. And again, it's the same thing. We're using P instead of 18 here to represent generally for any original price. If we have a 12% increase, this is an equation that represents that, as is this, and these are equivalent equations. Okay, so only need one of them, but if you have both, I mean, that's cool too. All right, and then finally, if the price of a hat after the increase is $35.84, what's the original price? Okay, so here my new price is $35.84. I'm trying to figure out the original price. And I want to think about what's the constant of proportionality. What do I multiply the original by to get the new? This equation makes that very clear. It's 1.12, okay, 1 and 1200ths. That is the constant of proportionality, right? If you look at it this way, that's fine. Like, you can write that equation, but you do have to recognize that when we're trying to find this original, the way to do it is to find that constant of proportionality and then divide by it, right? Because you're like working backwards, you're doing the opposite, going backwards in the proportional relationship. So if you do 35 divided by 35.84 divided by 1.12, you're going to get $32, which is the answer. Okay, you could also use the equation. The cost is 1.12 times the original price. The new final cost is $35.84. So to find P, the original, you divide by 1.12. Okay, you get that $32. Cool. So any way you want to do it is fine. In this question, because it doesn't say use the equation, but this is basically the same as this question, except here I'm checking that you use the equation to do it. So you can use this, but you ultimately do have to write it down that way, because I want to make sure you understand the equation representation. All right, that's it. Good luck, everyone. You got this.